Hi, and welcome to this overview of the Snyk Developer Security Platform. We built the Snyk Security Platform because we fundamentally believe that developers are the right person to own security for their applications. This is important because the pace of digital innovation is so fast today that the only way to keep up with that is for developers to take care of security as they build their applications. But also because developers far outnumber the security people on your teams. And the only way that security can be an enabler to development instead of a bottleneck is by empowering those developers to handle security. Now, when we look at the modern application, it's not just the code that the developers write anymore, and it's not even the dependencies that they might bring in from the open source world. The modern application is made up of all different types of code. The cloud itself is just software, and it's all controlled by infrastructure as code. And so throughout the application stack, things that used to be controlled by a central IT team are now controlled by code and by software. And that's where we built the Snyk Developer Security Platform. So as we go through this overview, that's what I want to show you. We're going to start by looking at the different aspects of an application that Snyk controls. And that's exactly what we have in our sample application that we'll take a look at as we go through the Snyk platform. You can see here, we've got an application that's made up of many different microservices. Each of these services runs in its own container. There's multiple languages that are used. We can deploy this to Kubernetes. We have Terraform configurations. All of that is controlled and contained in a single Git repo. And that's exactly what's reflected in Snyk as well. What I've done here is I've imported that GitHub repo into Snyk. And you can see by doing that, it's captured all the code here, all the different types of code that are part of this project. It's captured the different open source dependency manifests that are available as part of this application. It's captured Docker files to start doing a container analysis. It's captured also Terraform and Kubernetes files. So I have all the different types in components of this application captured here just by doing this Git repo. Now I'm going to come back to the individual results of some of those tests here in just a second, but our whole goal here is to enable developers to handle security on their own. And that means Snyk really needs to work in the places where developers work. Now you're going to see more of the Snyk interface, but I also want to show you some of the other places that Snyk can work in this workflow. So part of that is having Snyk in places like the IDE. It's having it in their Git repos so that we do checks as they commit code. It's having it in places like CI/CD so that we can also run automated checks as code is checked in, as pull requests are merged, and before things get to the point of being deployed. So first, let's go back and take a look at Snyk inside the IDE. In this case, I'm working on a part of the application that's using Node. And so I have my package.json file here that determines all the dependencies that Node's going to use. And the first thing you'll see is that we have this little advisory that pops up that says that our advisor score is low. This is an early warning system for developers. What Snyk Advisor does is it does an analysis of your project, and it looks not only at the security of that package, but it looks at other key indicators to indicate whether this is a package that you really want to use or not. We look at things like popularity. Are a bunch of people downloading it? Has it been well maintained? Are people creating new updates for it on a continuous basis or not? How secure is it? That's the core of the Snyk check, of course, and the community around it. How many contributors are there to this project? You can see in this case it got a relatively low score because the maintenance isn't very up to date on this particular package. Now that's just an early warning system. That's not an actual security test. What you can see that we've done here is we have a plugin for Snyk that's installed in our IDE, and we've run a test against this application. All the different components of the application have been tested by Snyk. We have a Snyk open source test that's going through all those open source manifests and checking them for vulnerabilities. The Snyk code tests, which are checking our own first party code for any vulnerabilities that exist there. We also do quality checks against that code. We do configuration checks that would include your Terraform, would include Kubernetes YAML, and we run container security tests as well. Let's take a look at some of these. If I look at my open source test, in this case, I've tested a Java POM XML file. You can see that I found a couple issues. This one happens to be a license issue. Those are something that Snyk can point out to users so that they know what they're getting into. I have several other high severity issues in this XML. And of course, I have all the security details that I might want. But probably what's most important to a developer is to know how to fix this particular application. And so they can come right into this description and they can see how to fix this application and fix this particular component. The same thing happens with the other aspects of Snyk. So for instance, in one of my Node.js code files, I have a cross-site scripting vulnerability. This is in the actual code I wrote. And you can see that it shows me the steps through my code where this vulnerability is introduced and how it actually gets consumed by my application. And you can see that it's given me suggested fixes again so that I can take care of that particular issue. If I go to configuration, you can see that it's telling me I've got a Kubernetes file that has a potential configuration issue, and the same with container tests. With container tests, I can see all the vulnerabilities that exist in those containers and I can dig into each one. But also with a container test, the other thing we can do is point you to a better base image. In this case, there's a slightly updated image that would reduce my vulnerabilities pretty drastically. And so I can make that change very easily in my Docker file. Now, the other thing we said is that we want to put Snyk into the Git repos where people work. Again, we looked at this Git repo before. You can see that Snyk is doing things like opening pull requests for me, suggesting pull requests that I might make that will make my application better and fix some of these vulnerabilities proactively. I can also open pull requests from the vulnerabilities that are discovered, and we'll see that here in just a minute. But another part of this is implementing checks that happen automatically on these pull requests. And Snyk can run through those checks automatically on those pull requests and provide input as to whether this check will pass and whether it should be merged or not. We've also implemented Snyk in another way here. We said Snyk should be involved in CI/CD tools. Those are other places where a developer spends a lot of their time. In this case, we've kept everything in GitHub. We're using GitHub Actions and GitHub code scanning to automatically scan as code is committed to a repository. So in this case, we've got a sample GitHub action here that uses Snyk and it tests my repository as code is committed. And you can see it's found several vulnerabilities in one of the Maven components that's part of this application. And those vulnerabilities show up in my repository as well. Now, another important aspect of this platform is, of course, the security. After all, this is a developer security platform. And so security intelligence built into the platform is really important. That'll come up in the way that we discover vulnerabilities and the information that we provide to a developer about those vulnerabilities, but it also comes up in exactly how we fix those vulnerabilities and recommend that developers take care of them. Now, that security intelligence has to be combined with application intelligence to make this all really work for a developer. And application intelligence really encompasses several aspects. First of all, as we've been talking about, it looks at all the different parts of the application, but also understanding how particular parts of that application work. How does information flow through the application? What code is actually executed? What packages are actually executed if I have a container and it's running live in Kubernetes? All of that is important for understanding what is the most important set of vulnerabilities to fix in my application. So let's take a look at security intelligence and application intelligence inside Snyk. Now, we're back in looking at a Java component in my application. This is the open source manifest for Java. And in this case, you can see the standard security information, CVE number, the CVSS score, a severity rating, all the typical things that you would expect to see from a security tool. But we can also see additional information. For instance, in this case, this particular vulnerability has a mature exploit available for it. That means it's probably fairly easy for a bad actor to try and exploit this vulnerability. This vulnerability is also reachable. The way that our code works in this case makes it possible for this particular vulnerability to actually be loaded so that somebody could take advantage of it. Those are both really important characteristics in determining what's the most important vulnerabilities to fix in this code, which is why a medium severity vulnerability is ranked above a high severity vulnerability. And you see that reflected in the vulnerability score that's shown over here on the right. The vulnerability scores in Snyk take into account the severity of the vulnerability, exploit maturity, reachability, and several other components to help a developer reason about what's the most important vulnerabilities to go through and fix. So you can see below we've got another vulnerability, and we have an insight here. This vulnerability, while it's high severity, and in this particular case, may not be all that bad for us. And the reason is that for this vulnerability to be exploitable, we know we have to have polymorphic type handling. Again, that's something that our security research team has built into this security finding. And so in this case, we've been able to analyze the code and determine that we don't have polymorphic type handling enabled. And so this vulnerability is probably not as bad. Now, from here, you probably want to go about fixing vulnerabilities. And again, if you're a developer, you could look through the details here and we'll tell you how to fix these vulnerabilities. For instance, we've got the fix information here, and we saw the fix information in the IDE as well. I could go back to my code and implement that, but I can also just fix this individual vulnerability by clicking a button and open a pull request. Or if I really want to, I can click a button and fix as many vulnerabilities as I want all in one pull request. What Snyk will do is logically work through all the different dependencies that are part of this application and work out what the most reasonable version is to go to that will both fix the vulnerabilities and not break my application. So we're not simply moving to the most recent version of a package. We're trying to move to a version of the package that won't break the application. That's a really important part of the developer experience. And we also have to look at all these different vulnerabilities and all the different packages that are part of this manifest, the dependencies of the dependencies and their dependencies as well, and determine the best route to fix as many vulnerabilities as we can in this particular application. That's part of this developer experience, making this as easy as possible for a developer to actually just implement these fixes straight away. Now let's look at our own code in the context of this application. As I mentioned before, this application is made up of multiple services, and so we have a number of different first-party code files that are part of this application as well, written in a number of different languages, and you can see that we've detected those automatically as we imported this code from the repo. You also saw that in the IDE we detected these. We could scan them in the Git repos or in CI/CD if we wanted to do that as well. In this case, the first vulnerability we see is a cross-site scripting vulnerability. And if I click full details here, it'll do a couple of things. One, it builds up the flow analysis, so I can see exactly how my code works and how this particular bit of data is flowing through my application and where that vulnerability is introduced with that bit of data. If I had multiple files, I could follow this bit of information through each file individually, but in this case, it just flows through one file. The other thing I have is the fix analysis. So again, I have samples here that will help me understand how I can change my code so that I can fix this particular vulnerability. And I also have a description of the vulnerability available to me here as well. If we go back to Snyk, there's one other interesting thing, and you may have seen this a second ago too. I have this ability to learn more about this type of vulnerability. This is using Snyk Learn, and essentially what we're doing is providing security education for developers built straight into the Snyk product, but also available for free outside the Snyk product. In this case, we have a cross-site scripting lesson, and as a developer, I can go through this particular lesson, I can learn what cross-site scripting is, and I can actually play around with it in the browser. I can create a sandboxed application and explore what cross-site scripting does and how you go about fixing it. Again, another important aspect of developer empowerment. We also said that Snyk will check all the infrastructure as code files, the configurations that make up this application. In this case, we have Kubernetes YAML, we have Terraform files, as well that all help to implement this application, to actually deploy it and make it run and get the environment set up for that as well. So Snyk infrastructure as code will go through and check these files for us, and again, provide the results that a developer can use very easily. We find the issue in those infrastructure as code files. We help a developer understand what that issue is and how to go about resolving these issues. Again, a piece of Snyk that can be implemented in your IDE. It could be implemented in your CI/CD flows. If you're a Terraform user and you use Terraform Cloud, you can use Snyk there. You can scan your Terraform plan files. Anywhere you want to implement Snyk, you certainly can. And then finally, Snyk also scans your containers. And we're going to look at containers in several different aspects here. First, the code that makes up a container. This is where containers start, and this is the place where Snyk starts with containers as well. Again, we saw container scanning in the IDE. Here we've imported a repo that has a Docker file in it, and so Snyk does analysis of that Docker file. What we're detecting in the Docker file is the base image that's being used by this particular part of our application. And here we can see that our application starts with a node image that's loaded with vulnerabilities. And again, to make it as simple as possible for a developer to fix, we have a button that we can open that will go back to that Docker file and change the base image to any of these that we might want to use. And of course, that can be automated. Now the Docker file, of course, is just the static contents. It's not the actual image. And so Snyk can actually scan your images as well. Often implemented in CI/CD, but another one that you could scan just about anywhere you want to. When we scan a container image, you can see that we again provide the base image fix advice, just like we did from the Docker file. We also produce all the vulnerability information about the individual vulnerabilities that are detected here. The fix details are in here too. So as a developer, I can use this information to go through and determine how to fix these vulnerabilities in my containers. But the other aspect of containers is that they actually need to run somewhere. That's what really makes them interesting. And in this case, we're deploying them to Kubernetes. Now, Snyk can also monitor our Kubernetes clusters and detect workloads as they're deployed to the cluster. Again, scanning those container images to look for vulnerabilities, letting you know that this container is actually live somewhere, and finding vulnerabilities. And as new vulnerabilities are discovered, alerting you to that fact as well. Some other interesting information comes up because of the fact that we're actually scanning these containers as they're live. So for instance, we provide information about the configuration of that container in the Kubernetes cluster. This information, this configuration detail, might make a vulnerability worse. And so here, for instance, we see that we've raised the priority score of this vulnerability because of the configuration. We also see all the other details that we saw before about vulnerabilities when we scanned them with Snyk. But something else really interesting is available here as well. Through our partnership with Snyk. Snyk is looking for threats and anomalies that happen as applications run. And they feed all that information back to the security and operations teams that's managing the cluster. But what they supply back to Snyk is information about those running vulnerabilities. So in this case, you can see we've got an image with over 500 vulnerabilities in it. But because of our integration with Snyk, we can see that only 34 of those vulnerabilities are actually from running packages in that live container. And in fact, only one of them is in a high severity vulnerability. So again, as a developer, I can look at this and I can reason about what the most important aspect of my application is to fix. In this case, I've got a high severity vulnerability in a running container that's actually in a package that gets executed. And of course, this platform is extensible. As your developers are going through and finding and fixing vulnerabilities, we can integrate with their Git repos. We can integrate with your tools like Atlassian, your CI/CD tools, your infrastructure as code tools, and your cloud, of course, as well. And across all of these applications that might be tested, we provide the governance that you need to show that developers are actually taking care of the vulnerabilities that they're detecting. So you know with assurance that your risk is being reduced. So that's our overview of the Snyk Developer Security Platform. If you want to try Snyk, you can go to snyk.io and try it for free.